All right, now we're going to talk more about phase changes and what happens when we heat something up. This is going to be a heating curve for water. Now the same kind of principle applies for any substance. It doesn't matter what substance we're doing. The exact temperatures will change though. Okay, so here I just have an X and Y plot, and I have temperature on the Y on the vertical and heat added on the horizontal. And what we're going to do is we're going to start off way down here in the corner, and we're going to start with really cold water, which is otherwise known as ice. And we're going to warm that ice up. And as we add heat to the ice, its temperature will rise. Okay. So here we have ice. And at some point, the temperature will stop rising. And what temperature will that be? Well, pretty simply, it's 0 degrees Celsius. That's the normal melting point for water. Okay. Normal melting point. And the normal melting point has a definition that we won't worry about right at this second. Just suffice it to say that that's where the temperature at which the water will melt, the ice will melt. Okay. Now what's going to happen is interesting is the temperature won't change, okay, for a little bit. And then it will start to go up again. Okay, the temperature will start to go up again. Now it's going to level off again. Oh, let's talk about the yellow part first. I'm sorry. What's happening here? Well, this is melting or fusion. It's melting going that way. And if we're going to reverse everything, it would be freezing going that way. Okay. Now the purple here, this is liquid water. I guess I should put in parentheses, this is solid, just to make it generic for any substance. Doesn't matter if we're dealing with water or, I don't know, benzene, which is a common chemical in chemistry labs. Okay. Now, we're going to have another plateau where the temperature does not change. This one's longer. I'm kind of exaggerating it, but that's okay. And now, if we go back to the y-axis, put a mark there, what temperature is that? 100 degrees Celsius. That's the normal boiling point. Okay, and this would be called vaporization. And opposite of vaporization is condensation. Condensation going that way. Okay. And now what happens is the temperature goes up again, and that's where we have, we could call it steam, we could call it vapor, water vapor, we could call it just simply a gas. And so what's going on here? The key is what's going on at those two plateaus, the yellow and the red, okay? At those two plateaus, all the energy is going into overcoming phase change. I'm sorry, it is going into overcoming IMFs at phase change. So the reason the temperature doesn't change in the yellow portions and the red portion is because energy is not going into making molecules move faster, it is going into ripping intermolecular forces apart. And the more intermolecular forces there are, or the more we have to rip them apart, the longer the plateau, the more heat we have to add for that process to occur. Okay. And one other thing I want to point out while we're here on this graph is the equations we would use to calculate the energy at each spot are different. So at the blue, and in the next video we'll do an example, we would use Q is equal to MC delta T, okay? At the gold, we're going to use Q is equal to N delta H fusion. Purple again, Q is equal to MC delta T. Red, Q is equal to N delta H vaporization. And then up there in the green, again, Q is equal to MC delta T. And what is the N in the red and the yellow? N is moles. Because remember, delta H vaporization, delta H fusion, that is per mole of substance. We'll use that in the next video.